Good morning, students. Can you able to see the PPT screen? Can you able to see the screen?
No, ma'am.
Now, can you able to see the screen?
Yes, ma'am.
Yeah. Okay, Naveen has joined or not? Okay, we were discussing about the module 2 of software quality assurance. We started the class 2 weeks before. So in module 2, we are going to discuss the following topics like test management, testing life cycle, role and activities. The screen is visible to you all. So the topics like testing life cycle, roles and activities, test planning, forming a test team, develop test plan reviews, test case design strategies. And then we discussed a black box testing approach like random testing, equivalence class partitioning, and boundary value analysis. White box approaches like test adequacy criteria, coverage and control flow graphs, paths, loop testing, mutation testing. So I think up to black box and white box testing we discussed in the previous class. So Ahmed, any doubts so far?
No, ma'am.
Can you able to hear my voice?
Yes.
So we started with the testing life cycle and Gogbi, are you there? Can you able to hear me? Gogbi, can you able to hear me? I think you need to join in the Google Classroom. I will share you the Google Classroom code. If you join in the Google Classroom code, you will find the materials of Unit 1, Module 1 and Module 2 PPTs, as well as the previous class Zoom recordings. Can you able to hear me? Gogbi? So I will share with you the Google Classroom code. Through that, you can join the Google Classroom. You will find all the material. So we started with what is software engineer testing. Then we saw the testing life cycle stages. Then we discussed the differences between software development life cycle and software testing life cycle. Then we discussed skills required for software testing. What is software testing? And how to carry out the test management. So while performing the software testing, how to perform the test process by using the various stages of test management activities. Then we saw the major difference between test plan and test strategy, and the levels of software testing like unit testing, integration testing, system testing, and acceptance testing. Then we saw the major difference between software development life cycle and software testing life cycle. Then we discussed the major topic called forming and test team. While creating and test team, who are all the team members of the software testing team. Then we discussed the roles and responsibilities of test plan, test design, and test execution process. Then we discussed the software testing management activities. So how the various test activities are carried out. Then the deliverables of software testing, how the software, what is the relationship between the test policy, test strategy, project test plan, and the different types of software testing activities like acceptance testing, system testing, integration testing, and component test plan. Goge, can you able to hear me? For you, I think you missed a few classes. I will conduct a separate class for you. Okay, don't worry. Can you able to hear me? Gogbi? Then we discussed the key sections of software, the various elements of test plan and the test case. While performing a test club plan and test case, what are the elements we need to consider? The various subsections of and the entries we need to make it in test case and test plan. Then we saw some few exercise questions with respect to software testing. Then we discussed software test case review process, how the review will be carried out, what are the major steps we need to follow. Then we discussed the major difference between automated testing and manual testing process. So what is manual testing and automated testing? In manual testing, what are the steps we will follow? In automated testing, what are the major advantages? And the tools available for automated testing, software testing tools. Then we discussed the software testing roles and activities. The major role of software test manager and the testing team and its responsibilities. So in every testing team, software testing team will have test manager, test lead, usability test engineer, manual test engineer, automated test engineer, network test engineer, and environmental specialist. Then we discussed the test case design strategies. Ahmed, any doubts so far?
No, ma'am.
Then we started with the black box testing approach. Under black box testing approach, we have random testing, equivalence class partitioning, and boundary value analysis. So if you take random testing, the testing will be performed in random. So there is no, if you cannot able to perform or follow other testing methods, we can go for random testing. Then we discussed when we can make use of random testing, how to make use of random testing, the main types with the random testing, major example, the major advantages and disadvantages of random testing, and the random testing tools available. So like the JCheck, RAND is. Then we started with the black box approach. The second concept called equivalence class partitioning. In equivalence class partitioning, we discussed what is equivalence class partitioning, what is the definition. Here in equivalence class partitioning, we will divide the testing code into two, will create valid test cases and invalid test cases. Based on the valid and invalid test cases, we'll create the equivalence class testing. We'll create the invalid test cases separate and valid test cases separate. By grouping the valid test cases into one class and invalid test cases into another class. From each class, from the equivalence classes, we'll identify a particular point. So how to identify the valid and invalid test cases based on case study we discussed. So these topics we already discussed. Ahmad, any doubt in those topics?
No, ma'am.
Gagoi, I will take separate class for you to explain the missing topics. Then we discussed in black box testing itself, we have three major techniques: random testing, equivalence class partitioning, and boundary value analysis. So we have some drawback in random testing as well as equivalence class partitioning. Those two drawbacks can be overcome by boundary value analysis. In random testing, we'll perform the testing in a random manner. We will not consider the major constraints, boundary values, and equivalence class values. So to overcome the drawbacks in random testing, we are using equivalence class partitioning, where we will divide the test case into valid test cases and invalid test cases. So we are giving importance to valid as well as invalid. But we won't consider the boundary conditions. Boundary conditions in the sense, the minimum and maximum boundary ranges. So that drawback can be overcome by making use of boundary testing method. Ahmed, where we stopped in the previous class?
Yeah, ma'am.
We discussed boundary value analysis in the previous class. It's discussed
No.
these boundary value conditions.
Yeah.
This discussed.
No, we didn't.
We discussed or not?
No, ma'am.
Okay. So in black box approach, the next topic is called boundary value analysis. As we discussed in boundary value testing, here we are considering the major boundary types. Say here we will take specification based testing techniques in which tests are performed using the boundary values. Boundary values in the sense minimum range and maximum range. Say for example, an exam has a pass boundary of 50%. So we know very well in exams, the students will be given marks from 0 to 100. Minimum value is 0, maximum value for exam score is 100. So here in that particular example, merit at 75% and distinction at 85%, the valid boundary values for this scenario will be as follows. So if you take an exam based boundary value, say an exam has the pass boundary at 50% and 75% for merit and 85% is called distinction. The valid boundary values for this scenario will be 49 to 50. If the student get 45 marks or 50 marks, he is pass. If he get 44 or 74 or 75, he is in the first class or merit list. And if he gets more than 84 and 85, he is in the first class with distinction. So that is the constraint. So in boundary values are validated against both the valid boundaries and invalid boundaries. So in boundary value analysis, how we will perform? We'll give some valid boundary values and invalid boundary values. If you give the value as 30, he is fail. If you give the value as 49, he is just pass. So the invalid boundary cases for the above example can be given as 0 for lower limit boundary value and 101 for upper limit boundary value. So the marks ranges from 0 to 100. If you give less than 0, it is boundaries limit is lower. If you give above 100, it is higher boundary. So from the diagram, you can easily understand in an examination marks class. So the marks ranges from 0 to 100. If he gets less than 0, it is lower boundary. If he gets more than 100, he is above the maximum boundary. In boundary value testing, what we will do means we will focus on the boundaries simply because that is where so many defects hide. So if you give minimum range and maximum range, one value above the minimum range, one value below the maximum range. So from that, we can identify the hidden errors. The most efficient way of finding such defects either in the requirements or in the code or through inspection. So actually in the boundary value analysis, so how we are performing the boundary conditions means, say for example, if you are checking an mobile number, say if you take any mobile number, errors tend to occur in the boundaries or equivalence classes rather than the center. So if you give the minimum range and maximum range, there won't be any issues. If you give one value less than the boundary and one value above the boundary, there may be, if the logic is not correct, or if some hidden bugs are available, that we can easily trace out. So in boundary value analysis, we are following the following steps. So first we'll identify the equivalence classes, then identify the boundaries of each constraint, Then create the test cases for each boundary value by choosing 1 point of the boundary and 1 point just below the boundary and 1 point above the boundary. So from this diagram, you can easily understand. So the circle states the boundary conditions. So they create the test cases to test boundaries of equivalence classes. So we are taking the entire test case. So in that we are identifying the boundary conditions. So the boundary conditions are, say we identify the equivalence classes. Within the equivalence classes, we are identifying the valid and invalid values, and we are circling the boundary constraints. Say from this example, we can easily identify, say the program accepts 3 to 6 inputs each, which are 5-digit integers greater than 10,000. So if we give any value less than 10,000 and any value greater than 999, so the value from the 10,000 to, so any minimum 5-digit value is 10,000, maximum 5-digit value is 99,999. If you give the value less than 10,000, that is they are the invalid and invalid inputs. So if you give less than 3 or between 3 to 6 or more than 6, the number inputs will be valid one. So from this diagram, we can easily understand our aim is to identify the minimum 5-digit number and maximum 5-digit number. So if we give one value, if here the boundary conditions are, if we give 4 nines, that is less than 10,000, that is invalid number. If we give 10,000, that is valid number. If we give more than 10,000, that is also valid number. If we give 999, that is valid number. If we give more, if we give 1 lakh, that is more than 999, that is invalid number. So like that, we are identifying the valid digits and invalid digits. Here, say for example, in the boundary value analysis, a number n such that, so we want to check the constraint minus 99. Then value of n ranges from the minus 99 to plus 99. So here the boundary conditions, the same way, if any phone number will have area code, prefix and suffix. So the suffix will have the actual 4 digits, prefix will have the country area code, and the values 200 999 will have the country code. So for the given constraints, the boundary conditions for the number n ranging from minus 99 to plus 99, the values will be valid. Boundary conditions will be say one value greater than minus 99 is minus 100, the same number minus 99, and one value less than 99 is minus 98. The same way, 99, one value less is 98, one value greater is 100. So like that, we will identify the boundary conditions. The same way, for validating the phone number, we will take the area code first, that is in 3-digit, then prefix for the mobile number and suffix of 3 to 5 digits. So based on the constraints, we'll check the boundary values. The major advantages of using boundary value analysis is very good at exposing potential user interface, user input problems. So by checking the boundary values, we can identify the user interface is working perfectly or not. It's very clear guidelines, and determining the test cases. Very small set of test cases are generated to check the boundary conditions. So the major disadvantage is it does not test all the possible inputs. So we are checking only the boundary conditions. We are not considering the internal values. Does not test dependencies between combinations of inputs. So it will check only the boundary conditions. It will not check the boundary value along with other values. The same way, Boolean and logical variables present a problem for boundary value analysis. So if your input is Boolean or logical values, Boolean means 0 or 1, on or off, true or false condition. So in that case, checking the boundary value analysis for Boolean values and logical variables is very difficult one. So any doubt with respect to boundary value analysis? Ahmed?
No, ma'am.
Boundary means what? The border. So we'll have the framework. So we with the border values are called boundary values. So to check any hidden errors are available in the boundary values or boundary constraints. So we'll go for boundary value analysis. So the next subheading is called white box approach. Under the white box approach, we have the following major subtypes: the test adequacy criteria, coverage and control flow graphs, paths, loop testing, and mutation testing. So as we are performing the testing, software testing process, here we need to check what is the criteria for performing the particular process. So if there is any hidden error in the criteria, that should be identified by using test adequacy criteria. The same way, coverage and control flow graph means, so the entire code, the logic, the application process can be tested by using coverage techniques. And control flow graphs, so the looping structures, iterative statements, and for loop, while loop, do while loop, or concurrent processing, recursive statements, function call and return, those kind of statements can be tested by using control flow graph. The same way, path means how the process, what is the input, where the input is given, how we are doing the process, how the output is generated. So the flow of data in the processing code can be tested by using path coverage. And the looping testing methods can be used for checking the looping statements, like the for loop, while loop, do while loop, switch case statements. So those statements in your program can be tested by using loop testing method. And mutation testing is, here we will create the mutant for the given program. So we will have the original program. For the given original program, we will create a mutant program, and we will apply the inputs on the mutant program, and we'll check whether the original program and the mutant program both are producing the same result or not. If both are producing the same result, then there is some error in the project. If they both are giving different results, then the program is logic is correct. So under the white box testing, we have the following testing methods: test adequacy criteria, code coverage, control flow graphs, paths, loop testing, and mutation testing. If you take the types of code based testing and adequacy criteria, we have the following techniques, like it is used to check the control flow of testing, statement coverage, edge coverage, condition coverage, path coverage, and cyclometric complexity. So cyclometric complexity in the sense time complexity and space complexity. So the logical structure of the program is appropriate or not, that can be tested by using cyclometric complexity testing methods. And the statement coverage techniques are used to check each and every statement of your project. And edge coverage testing, here we will use the flow graphs to check the any hidden errors in the edge. And condition coverage can be tested by using Boolean and sub-expression control flow graph techniques. So from this from this diagram, you can easily understand. We will take the test adequacy criteria. So based on the criteria, we will go for a system under test. We'll create the test case specifications for the given set of codes. The specification will be taken into consideration. All the specifications of your project is implemented in your code or not, that will be tested. For the given code, we'll create the test case. Test cases will be generated. Then we'll execute the test cases. Based on the test case execution, we'll check whether the testing results are as per the adequacy criteria or not. So accordingly, we will generate the test report. So this diagram gives you the complete structure of your software testing. So if you take software testing, we have the testing basic concepts and definitions. So in your project, we will check the basic concepts, logic, idea, algorithm that is used as per the technical aspects or not. So to check those parameters, we will use testing related terminology, theoretical foundations, and relationship to testing to other activities. So those methods are used to check your basic concepts. And if you take the levels of testing, we'll have the target of the test and objective of the test. So the target and the objectives of your project will be tested by using testing levels. And if you take the testing techniques, we have code-based testing techniques, fault-based testing, usage-based, based on nature of application, black box, white box, and selecting and combining the technique. In the same way, if you take the test related measures, we'll have the evaluation techniques and we'll have evaluation of test performed. And if you take the test management process, we'll have management concerns and test activities. So this will give you the various activities which are performed during software testing. So the detailed explanation for the concept is given. So we have major two types of software testing. One is called black box testing, another is called white box testing. What is white box testing means? So here it is a strategy in which testing is based on internal path, structure, and implementation. So if you know the program, if you know the logic, if you know the algorithm, if the project is written in Java, if you know Java very well, then only you can able to test. That is called white box testing. And it is and function is understood only in terms of its implementation. So the each and every internal line of code is tested by making use of white box testing. What is happening inside the project is visible to the programmer. Only the programmers who know the programming back end and front end can only able to perform the white box testing. Here we'll give the inputs and we'll check for the outputs. So any doubt with respect to white box testing? Ahmed?
No.
So white box testing can be applied to at all levels of system development. So we can under white box testing only we have unit testing, integration testing, and system testing. Unit testing means we'll take only one particular function. We will perform the unit testing. We will perform testing on first unit, second unit, or we will say the modules, module 1, module 2, module 3. So that is called unit testing. And if you integrate module 1 and module 2, then we'll perform integration testing. Once all the in your project, if you have 5 modules or 5 units, so we'll perform 5 unit testing. Once all the 5 unit testing are over, we will integrate the module 1 and 2, 3 and 4 and 5, and we will put together. We will create while connecting the modules, we'll perform the integration testing. So while integrating the modules, we'll perform the integration testing. Once all the 5 modules are integrated, then we'll go for the complete system testing. Generally, white box testing is equated with the unit testing preferred by developers. Usually, while performing the white box testing, you will perform the unit testing first, then we'll go for integration testing, then we'll perform the system testing. Usually for every project, we'll perform both white box and black box testing. So we know very well in black box testing is impossible to write a test case for every possible set of inputs and outputs. Some of the code may not be reachable without extraordinary measures, and specifications are not always complete. So the black box can be performed by non-programmers, say the person who don't know the programming language also can give some input and he can check for the output. So that black box testing can be performed by any end user. But in case of white box, if you know the coding, if you know the logic, if you know the internal constructs of your project, then only you can able to perform white box testing. It does not address the question of whether or not the program matches the specification. and does not discover the missing program logic. So there are some advantages in black box testing, and there are some disadvantages in white box testing. To overcome both the advantages and disadvantages of both the techniques, we are performing both black box and white box testing for all our projects. If you take the white box testing, there are major two types. One is called control flow testing. Second one is called data flow testing. What is control flow? Ahmed, any doubt? Ahmed?
Yeah, ma'am.
Yeah, what is
Hello?
control flow testing? Control flow means what? Can you explain? So we have control flow statements now. Say we'll give some input. The input will be given to some processing statements. The control will be transferred. Say in for loop, while loop, or switch case, do while do. So it will take some input. The input will be given to some processing statement, and the set of statements followed by the condition will be executed. It will produce some output. So we'll call it as the control flow statements are like do while do statements. So any executable statement in your project can be tested by using control flow testing. And data flow testing means how the data is passed from one statement to another statement. That can be tested by using control flow, data flow testing. Say in control flow testing, what we will do means it identifies the execution path. So how the data is passed in between the executions through a module of program code, and creates and executes the test cases to cover those path. So it will accept some input, it will do the processing, and it will produce the corresponding output. A path is a sequence of statement execution that begins at any entry point and ends in the exit point. A path means where the data is accepted, how it is transferred, and where the process ends. So in control flow testing is a structural testing strategy that uses the program's control flow as a model. So the control flow testing is a structured testing method. Control flow testing techniques are based on selecting a set of test path through the program. So the input will be given to a set of statements, and how the data is processed by so many statements is noted. So how the data flows from one statement to another statement is called path. Why we are using this control flows testing is it is most applicable to new software for unit testing. While checking each and every unit of your project, the control flow testing can be used. Control flow testing assumptions. Here we are making some assumptions. Based on the assumptions, we are executing the control flow testing. Specifications are correct. Data is defined and accessed properly. There are no bugs other than those that affect control flow. So we assume that there is no other bugs or errors available in our project. Only we are trying to identify the bugs in the control flow. It is in structured object-oriented languages, reduce the number of control flow bugs. If you are using structured methods or object-oriented methods, the number of bugs can be reduced. Say, based on the flow of control in the program, by using the control flow testing, we can easily test the logical decisions, looping statements, execution path, and it can complete the test cases, and we can ensure the control flow statements are free from errors. So here additional form for white box testing is, so we'll create, here we will follow two-step process. In step one, from the source to extract the control flow graph. We'll create a control flow graph and we'll give the input, and we'll check how the input is processed through the control flow graph, and design the test case to cover certain elements of the graph. So here in control flow, we'll use the graph-like structure to identify the flow of data. Say in control flow testing, what we will do, we'll create the process blocks. So we will use some notation called process block. A process block is nothing but a node where it accepts inputs and it produces some output. And in the control flow graph, we can have the nodes with one input and one output, or we can have the node can have one input and it can produce two outputs. Say it will accept some value. If A is greater than B, then print A or print B. Or it can produce one, it can accept one input and it can produce three or four outputs. So this kind of control flow is used for switch case statement. So in switch case, we will give some one input, and depending upon the value of the input, it will branch to any of the switch cases. And in the control flow graph, we can have junction point. So junction point is nothing but where two inputs are given to the node and it produces one output. Say these are the some of the control flow graph. So the control flow graph can be a sequence graph, or it may be an if then else. So if you are using if then else, what we will do? So we'll get one input, and if the condition is if A is greater than B, value of A is accepted. Then if A is greater, then it will print A, or if B is greater, it will print B. Then it will come to the junction point. Or if you are checking the switch case statement, so we'll take the value for switch. Then based on the value of switch value, it will branch to say if the value is Monday, Tuesday, Wednesday, Thursday. So it will say Monday to Friday working day, Saturday, Sunday is weekend holidays. So one input given to more than one cases, then it will produce one output. If you like to create the control flow graph for while statement, so the while statement control flow graph will look like this. While if the condition is true, then execute this. If the condition is false, do other alternative option. If you want to represent the control flow graph for repeat until, repeat the statement until the condition is satisfied. So these like this will create the control flow graph. Then we will check for the error, hidden error in the control, error in the given code. Say for the given sample program, they drawn an control flow graph. So the given example program is having some lines like assignment statements A equal to 1, B equal to 2, C equal to 3. So all those assignment statements are given in the first node. Then we have one if statement, if A is greater than A is double equal to 2. So that is represented, the condition checking is represented using if A equal to 2. If the condition is true, then it will print X equal to X plus X by 2. The condition is false, it will display other option. Then we have one more assignment statement, P equal to C divided by B plus C. So that is given after executing the if statement, it's executing the assignment process. Again here that is given as input to the if statement. If B is B divided by C greater than 3, then there is a branch. It will go to Z equal to X plus Y. Else it will exit from the function. For the given sample code, they drawn the control flow graph. Any doubt in this? After drawing the control flow graph, we will check for the errors, hidden errors, whether the flow of data is correct or not. Any doubt?
No,
So
ma'am.
we are taking the sample code. For the given sample code, we are drawing the control flow graph. Then we will perform the testing on the control flow graph. So after so the code is mapped with the, we have the sample code, we have the control flow graph. The code and graph is mapped. So here what we will do, we'll by using the control flow graph, we can check the code coverage as well as test coverage metrics. So here by making use of the control flow graph, it can cover the statement and line coverage. Each and every line of your project can be testing. As well as we can check for the decision and branching statements. We can check the condition, as well as the multiple condition coverage can be tested. Decision and condition coverage can be tested. Loop coverage as well as path coverage can be tested. So what is statement coverage means? So we know very well, every program will have a number of statements. It may be assignment statement or executable statement or looping statement. So the corresponding statement will be represented by using control flow graph. Then we will perform the testing to identify the hidden errors. So here for each test case, we need to specify the inputs of the component, identification of statements to be executed by the test case, the expected outcome from the test case. Once the test compliance criteria is found, the percentage of the statements in the software which were executed at least once. And the entry into the programming language, which is typically the smallest individual unit of the execution. Statements are a number of statements, forms and function. So each and every statement in your project can be tested by using control flow graph. So here what is the statement means, x equal to 1 is an assignment statement, e equal to 1 by x is an that is also an assignment statement. So each and every statement in your project will be tested by using control flow graph. And what is statement coverage means? So we'll take the statement like begin if y is greater than or equal to 0, then perform y equal to 0, else perform abs equal to y. So here the corresponding test case 1 will be the input for what is the input for y, and what is the expected result from the statement, and what is the actual result. So everything need to be recorded before performing the test case. So the corresponding flow graph for the given lines of statements is given. So we will take the begin, the assignment palindrome, and the checking if condition is taken in diamond symbol. If the condition is true, we will make an assignment statement. If the condition is false, it will go to another assignment statement. While creating the statement coverage for the given if statement, we created the statement coverage flow graph. And what is the input for y, what is the expected result, and actual result received from the test case, everything will be recorded. So this particular diagram shows you how the statement coverage is done for the given if statement. So the results, test case results are if y is 0, the expected result is 0, and the actual result will also be 0. While performing the statement coverage, how the data is flowing in between the various lines of statement. We will start the process. We'll take the value for y. If the value of y is 0, then it will go to greater than or equal to 0 means then it will go to assign y equal to 0, else it will go to return y and end the process. So here the test case is 1. Actual input given for the process is 0. If you give the value of y equal to 0, then the expected output is 0. Actual output also 0. So the statement or if statement is completely tested. Any doubt in the statement coverage? So like that, we need to create the test cases for each and every statement in your project. Naveen, any doubt?
No, ma'am.
So far we discussed control flow testing and statement coverage. Control flow testing means for the given code, we'll create the control flow graph. Then we'll assign the values for the particular statement. Then we'll check whether how the processing is going on. By seeing the graph itself, we can identify any errors are hidden in the statement or not. In statement coverage, what we will do, we'll create the statement flow graph for the given code, and we'll assign for all input variables, we'll assign the corresponding input. Before starting the test case itself, we'll give the assign the input value and record the expected output and actual output. If expected output and actual output both are matching, then the statement coverage is done. The next topic is called line coverage. So we discussed control flow testing, control flow graphs, and statement coverage by using statement coverage flow graph. Next is line coverage. Line coverage means each and every line in your project need to be tested, whether the line is logically correct or not, and as per the specification it is correct or not. So coverage means we are covering the line, or we are covering the flow graph, or covering the statement, and we are performing the testing, like unit testing, integration testing, and system testing. No? The same way we are performing line coverage, statement coverage, and flow graph. So each and every line is tested by using line coverage. Each and every statement is tested using statement coverage, and by using flow graph, we are testing the overall flow of data. Here, the software developers and testers commonly use the line coverage because it's simplicity and availability. And the line coverage is the weakest, indicating the fewest number of test cases. So in a line coverage, the number of test cases will be very less. Bugs can be easily occur in the test cases. The line coverage cannot see. So in line coverage, the most significant shortcoming of line coverage is that it fails to measure whether you test a simple if statement with a false decision outcome. Experts generally recommend only to use line coverage if nothing else is available. So if you cannot able to test all your project by using system testing, integration testing, and overall system testing, we can go for line coverage. Line by line, we can check for the bugs and errors. So if line by line, your project is free from errors, then it means your units are free from errors, and your integrated system is free from error, and your overall system is free from error. The next coverage is called decision or branch coverage. So in every program, we'll have executable statements. Each and every executable statement can be tested by using line coverage. And if you will have branching statements, the branching statements can be tested by using decision and branch coverage techniques. And the control flow can be tested by using control flow graphs. And the statements can be tested by using statement coverage flow graphs. So in decision and branch coverage, what we are doing is, it is designed in order to execute each outcome of the or all selected decision points in the test object. An executable statement which may transfer control to another statement depending upon the logic of the decision statement. So we know very well branching statements means if then else, nested if, else if ladder, switch case, and do while do, or for loops. So all those things will come under branching statements. So we'll check for some condition. If the condition is true, it will execute one set of statements. If the condition is false, it will go to another set of statements. So there will be a branching, this branch or that branch. So they given you one simple example, A equal to true, or if B or C is false. So if it is a logical or Boolean expression, if the value of A and B both are 1, then only the output will be 1. And if any one true or so, that is if you are using the logical and or not based on and means if both the values are 1, then only the output is 1. If it is or, if any one value is 1, then the expected output is 1. The particular diagram shows you how the decision coverage can be done. Say for the given code, if y is greater than or equal to 0, then y equal to 0, else AB is equal to y. So for the given code, we drawn the flow graph. We will start the process. By using the diamond symbol, we are mentioning the y is greater than or equal to 0. If the condition is true, then it will assign y equal to 0. If the condition is false, then it will come to ABS equal to y. So for the given decision making statement, we draw on the decision coverage flow graph. Then we'll assume the expected, or we'll assign some value for y, and what is the expected result, what is the actual result. So we'll create the test case 1 for yes condition and test case 2 for no condition. So in test case 1 for yes condition, if the y input is 0, then the expected result is 0 and the actual result also 0. In case of test case 2, no condition, the input y is -5, the expected result is 5 and the actual result is -5. So the expected result and actual result both are mismatching. So there is some hidden error in the logic. So any doubts so far? So far we discussed control flow testing, statement coverage, line coverage, and flow graph, and decision coverage.
No doubt.
So I added more slides for your understanding purpose only. You can 1 or 2 slides is enough. The definition what is enough. So the next topic is condition coverage. So the same way condition will check for the constraints. If the condition is satisfied, then it will execute in if statement. If the condition is true, then it will execute statements followed by if. If the condition is false, then it will execute the statements followed by else part. So for the given code, we are drawing the flow graph and we are taking the test case 1 for true, false. Because here we have 2 variables, x and y. If x is true and y is false, what is the input? What is the expected result and what is the expected actual result? The same way test case 2 is framed for x is false and y is true. If x is false and y is true, what is the expected result and what is the actual result? If x is true, we are assigning x equal to -4, y equal to 12. And here we are assigning x equal to 12 and y equal to 0. Then accordingly, we will get the corresponding output. So here also in the condition coverage, they given you one code. We are assigning the test cases as true or false. We are assigning the test cases as true, false, and false, true. If x is 3, y is 7, the expected result is false and actual result also false. If both expected result and actual result both are matching, then the logic and specification is correct. If they are not if they are expected and actual results are mismatching, means there is some hidden error in the project. In the same way, we have branch condition combination. So there is a branching statement as well as conditional statement. If both based on the condition, we need to branch from one statement to another statement. So those kind of statements can be checked by using the inputs of the component, the expected outcomes of the test case, which can show which branch is covered. Here we will take, if you are giving n Boolean operands, we may get 2 power n test cases are required to achieve 100% coverage. So if your project is having n variables, then we need to perform 2 power n combinations to check all the constraints. Say if your lines of code is having the variables x and y, we have 2 variables x and y, so we need 2 power n, that is 2 power 2 combinations. So we need to go for 4 combinations to identify all the branch conditions. The same way we can have multiple condition coverage. So here we can see there are more than one condition. The first condition is x is less than 10. Another condition is y is greater than 10. So we have the complex expression. If both the conditions are true, then it will execute z equal to file of x comma y. If first condition is false, second condition is true, then it will call the function f of x comma y. So we are taking we have two variables and two conditions. So we are taking 4 combinations. Test case 1 for true, comma true, test case 2 for true, comma false, test case 3 for false, comma true, and test case 4 for false, comma false. Same way, multiple condition coverage. So we can take so for your understanding purpose only, I have given you more examples. You can just go through and you can choose any one example. The next testing method is loop coverage. So we know very well we are using different looping structures in our projects: for loop, while loop, do while loop, switch case, and conditional operators. So those kind of statements can be easily tested by using loop coverage flow graph. So here the diagram shows you how the looping statements can be represented using flow graph. So we are starting with iterations. Looping statements will have iterations, n number of iterations based on the n value. For I equal to 0, I less than 10, I plus plus means we need to repeat it for 10 times. So based on the value of n, we need to repeat the process. So here the diagram shows you how the simple looping statement can be created. So we are starting with the loop and we are entering into the A statement. Then it will go to B statement. Based on the condition, it will repeat the iteration. The same way, here in the second one, concatenated, we have concatenated. So concatenation means combine both A plus B. So we have two iterative statements. The third one is presents nested loop. So within one for loop, we have another for loop. So outer loop as well as internal loop for I equal to 0 and for j equal to 0. So we have two iterative statements. And the fourth one represents unstructured looping statements. So if it is unstructured means we may have within for loop, we may have a while loop, or we may have within switch case, we may have do while do, like that. So two different looping structures are integrated. So this diagram shows you how the nested looping structures can be represented using flow graph. So start the innermost loop. So from the diagram itself, we can understand we are starting the process. It goes to the step A, then it checks for the condition B. If the condition is true, it will go to C. If the again, it will check one more condition in condition C. If the condition needs to be repeated, it will go back to B. Then it will come to D. Again, it will go back to A. So here it is a nested looping structure. So in case of nested looping structures, the innermost loop will be started. When it reaches the maximum value, it will come out from the inner loop and it will go to the outermost loop. So any doubt with the loop coverage?
No, ma'am.
So far we discussed the white box testing approach. Within that, we discussed what is test adequacy criteria, then coverage. So in coverage means statement coverage, loop coverage, what are the types of coverage? Control flow graphs, data flow graph. So those statement coverage, line coverage, loop coverage, branching coverage, and control flow graph. And so those are the coverage statements we discussed. Then we discussed control flow graph to generate the loop coverage. So you go through these topics if you have any doubt.
Okay, ma'am.
You have any other class after this?
No, ma'am.
Shall we complete this path testing? Because so that the white box will come to an end.
Okay, ma'am. Yeah.
So what is path? I think you might have studied path in tree structures, graph structures. Path means from the source point to end point. So if
Yes,
you
ma'am.
have A to B, B to C, C to D, so the path is called A to B, B to C, C to D. That is a path. Or we can say the edges which are connecting the nodes. So here in path testing, what we are doing is, the objective of path testing is to ensure that the set of test cases in such that each path through the program is executed at least once. So you might have studied in shortest path, or so that is source to destination. If you want to find out the shortest path, what we will do, we will start from the source, then we will look for the edges which is having the lowest distance, that we will choose. Again we will go to the next node, there we will look for the edges which are having the lowest distance. So we'll find out the shortest path from the source node to the destination node, like a traveling salesman problem. So we'll find out the path from source to destination with the shortest distance. The starting point for path testing is a program flow graph that shows nodes representing the program decisions and arcs representing the flow of control. So we'll have the nodes and edges. The nodes are connected with through edges. Arc is nothing but the edges are connected through the nodes. Statements with conditions are therefore nodes in flow graph. So each and every statement will be represented in the form of nodes. In path coverage, what we will do, we try to the path is a sequence of branches or conditions. If one node is connected with another node, that is called an path. So from the diagram we can say for example, we are trying to find out the cyclometric complexity of the given program. We know very well cyclometric complexity is based on the time complexity and space complexity. So how much time we need to execute the program and how much space we need to store the project. So that our idea is to find out we need a less time as well as very less space to store and execute the project. So if you're for given n inputs, if you are able to produce log n, then the complexity is less. If it takes order big O of n square, the complexity is high. Here from this diagram, so we will take compute the complexity of the program. What we will do, we will take the number of edges. Edges means the line, nodes, how many nodes we have in the project, and P, how many path we have. So here, number of nodes is 2 and path is 1, and the path also 1. So here, if you take the next one, we have 4 nodes, 4 path, and 4 edges. So by counting the number of nodes and counting the number of edges and the looping statements within the nodes, we'll count the complexity. Say for this given code, we are starting from A and we are moving to B and C. Then we reaches D. Again, it branches to E, F, G, H, I, J, like this. So based on that, we are counting the number of edges as 16, number of nodes is 13, and the path is only one path. So using a single path, we can reach all the nodes. So the V of G complexity is 5. So the formula they given for this computation is V of G equal to vertices of G equal to E minus N plus 2P. Okay, go through the topics up to okay, we'll stop with the topic loop testing. Okay, go through the topics content up to this. If you have any doubt, you ask me in the next class. Okay. We will discuss the mutation testing in the next class.
Okay, ma'am.
I think there are more slides that I need to. I will cut down for your explanation purpose. I added all those points, but you need not. I think it's more than 350. How many slides are there? More than 305 slides are there. Okay. I will upload one more updated PPT. So you go through the topics: loop coverage, control flow graphs, path coverage, statement coverage. So you go through the content. If you have any doubt, you ask me in the next class. Okay.
Okay, ma'am.
Are you free tomorrow? Can we have class tomorrow?
Yes, ma'am.
Okay, ma'am.
Yeah, and Gogai, Naveen, you please tell him how to join the Google Classroom.
Okay.
I will share once again. I will share the Google Classroom code with in your WhatsApp group. You tell him to join Google Classroom. There we have material. Module 1, module 2, as well as Zoom recordings also there. No?
Yeah.
Yeah. So if you have any doubt, sorry.
Okay.
Rahul.
Good afternoon, ma'am.
Yeah, you join in the Google Classroom. You will find all the material, module 1, module 2, and the Zoom recordings also available. Okay.
Google group.
Yeah, I will share you the link. If you click
Okay,
on the Google Classroom link through your email ID, you can join.
okay, ma'am.
And you go through the PPT. If you have any doubt, it's more. I used more pictures to easily understand. If you have any doubt, you can ask. Okay, shall we end the class?
Yes, ma'am.
Okay, ma'am. See you.
Okay.